Welcome to this lesson on Retrieval-Augmented Generation, usually called RAG, with Amazon Bedrock. This is one of the most important topics for the AWS Certified Generative AI Developer Professional exam because it connects foundation models, company data, embedding, vector stores, security, and evaluation. In this video, we will keep the explanation practical. By the end, you should be able to explain what RAG is, why it is used, how a RAG pipeline works, and how Amazon Bedrock knowledge base helps developer build RAG applications on AWS. This exam is not only asking whether you know generative AI vocabulary, it is testing whether you can build real generative AI applications on AWS. RAG is important because many applications need a model to answer using private or up-to-date documents such as policy manuals, product documentation, support tickets, legal documents, or internal knowledge. The key exam idea is this. If the company wants to use its own documents without retraining the foundational model, RAG is usually the best answer. Instead of changing the model itself, the application retrieves relevant information and gives it to the model as content. Before explaining RAG, first explain the problem. A foundation model is trained on large amount of data, but it does not automatically know a company's private documents. It may also now know information that changed after training. For example, if a customer asks about company's latest refund policy, the model might give a generic answer unless the correct policy document is provided. The model may also make up details if it tries to answer without information. RAG helps by retrieving the relevant document's content first, then giving that content to the model so the answer is more grounded. RAG stands for Retrieval-Augmented Generation. Break the term into three parts. Retrieval, which means the application searches for relevant information from a trusted data source. Augmentation means the application adds that retrieved information into the prompt or contents given to the model. And generation, which means the foundation model uses that context to create the final response. A simple way to say it is RAG lets an AI application answer using external knowledge at a request time. It does not require retraining the foundation model every time the document changes. Here is the basic RAG pipeline. First, the user asks a question. Second, the application converts that question into an embedding, which is a numerical representation of meaning. Third, the application searches a vector store to find document chunks that are similar to the answer. Fourth, it retrieves those chunks. Fifth, it adds that chunk to the prompt as context. Finally, the foundation model generates an answer using the user question plus the retrieved context. The most important thing is to remember that the model is not directly browsing your database by itself. The application layer retrieves relevant information and passes that information to the model. Embeddings are central to RAG. An embedding model converts text into a vector, which is a list of numbers that represent meaning. Text with similar meaning produces vectors that are closer together in vector space. During ingestion, documents are split into chunks. Each chunk is converted into embedding and stored in a vector store. During a user query, the question is also converted into an embedding. The vector store searches for chunks that are closest to the query. This is why RAG can find relevant information even when the user does not use the exact same words as the document. For an exam question, watch for words like embedding, vector database, similarity search, chunks, and metadata filters. Amazon Bedrock knowledge bases are important for the exam because they provide a managed way to build RAG applications. A typical setup starts with a data source such as a document stored in Amazon S3. Bedrock can process the data, split it into chunks, use an embedding model to convert to create vectors, and store those vectors in the vector store. At the query time, the application can retrieve relevant chunks and generate an answer with a foundation model. AWS documentation describes knowledge bases as supporting RAG workflows by retrieving information from your data source and using it to generate context-specific responses. For the exam, remember that knowledge bases are useful when application needs grounded response from enterprise data without custom building every part of the RAG pipeline. RAG quality depends on several design decisions. Chunk size matters because chunks that are too small may lose contents, while chunks that are too large may retrieve irrelevant information. Overlap can help preserve contents across chunk boundaries. The embedding model matters because it controls how text meaning is represented. Top K retrieval controls how many chunks are returned. Metadata filtering helps restrict results, for example by department, document type, product, region, or access level. Reranking can improve the ordering of retrieved results. Source citations help user verify where the answer came from. Security is also part of design. A RAG system should not retrieve documents the user is not allowed to see. For exam, look for options that improve relevance, grounding, and access control together. In exam question, it may simply ask what is RAG. They may describe a problem and ask for the best fit. If answers are irrelevant, improve retrieval. That may mean better chunking, better meta, data filter, adjusted retrieval setting, or re-ranking. If facts are missing, check whether the documents were actually ingested and indexed, whether the documents are current, and whether the documents has permission to retrieve them. If the model hallucinates, make the prompt rely more strongly on retrieved contents and evaluate groundedness or faithfulness. If restricted data is exposed, the issue is not the model's creativity. It is an access control and government issues, so you should apply IAM, encryption, logging, and document level access rules where appropriate. Now let's answer a quick exam style question. A company wants a chatbot to answer questions from internal policy documents, but it does not want to retrain a foundation model. The best answer here is B, which uses RAG with a vector store and a Bedrock knowledge base. The key clues are internal documents, no retraining, and the need for grounded answers. Training a new foundation model would be expensive and unnecessary. Increasing temperature changes randomness, not document knowledge. Removing access control is unsafe and wrong. So, when you see private documents plus no restraining, think RAG. That is the end of this topic. The main idea is simple. RAG combines retrieval with generation. The application retrieves relevant information from trusted sources, adds that information to the prompt, and then foundation model generates a grounded answer. You also learned why embedding and vector stores matter, how Amazon Bedrock knowledge bases can simplify the workflow, and which design choices affect answer quality, latency, cost, and security. Thank you so much for watching this video. In the next video, a strong follow-up topic would be agents for Amazon Bedrock because agents build on foundation models and can connect model reasoning to tools, APIs, and business workflows. These are the official AWS sources used to keep this lesson aligned with the current AIP C01 certification and Amazon Bedrock knowledge bases documentation. Before recording It is a good idea to open the official documentation and check whether any service name, feature name, or supported vector stores have changed. Thank you so much for watching me. I will see you in the next video. Until then, take care.